Hi everyone, in this video we are talking about root mean square aka RMS. Why we need RMS? Why RMS? In DC circuit, if we want to calculate the power, it's easy. If we want to calculate the power, it's easy. We just use voltage times current, we got the power. But in AC circuit, if we use voltage times current, we only got the instantaneous power. However, we want to know the power in a period. Or we can see we want to know the average power delivered in this circuit at same amount of DC source. So how does this work? You might think of average, right? If we want to use one number to represent a group of number, we use average, right? But why we don't use average value? If we have a sinusoid AC source, this is voltage, this is T, the average of this voltage is 0 because the average is the area under the waveform. The average voltage of one period is 0, and we know we use 0 to time anything, the power is 0. But is the power really 0? We actually deliver power onto our load. The load actually consuming power, so the power is definitely not 0. We can't use average value. That's why we came up with RMS value. RMS value is equivalent value, or we can say effective value of an AC waveform. Okay, so then we move to the next question. How to calculate RMS value. The definition of RMS value is F RMS equals to square root average on period there to T square of function and dt. Don't scared of this long equation. I'll next talk about 3 common waveforms. In 80% of time in your future study or your future work, you'll only use those 3 type of RMS value. So let's talk about RMS of common waveform. The first one we're going to talk is sinusoidal waveform. As we talked in the first video, we can use y equals to a sine omega t plus phi to describe the waveform. In RMS value calculation, we only care about one period. This phi really doesn't influence our result. So now it can become y equals to a sine omega t. Then we put this equation into our definition formula. Our RMS value is 1 over t from 0 to t a sine omega t square dt, right? And we put this square root in here, which is 1 over t and 0 to t a square root times 1 plus cosine 2 omega t divided on 2 dt and our square root. we got 1 over t and a times a square root, and for half of for 1 over 2 is 2t over 2 plus this part is 0 and sorry, this we got a bracket here. No, here. Yes. And then we got a square divided on t square root, and then we got a divided on square root of 2. Yes, that's the RMS value of sinusoid waveform. Then we move to next common waveform. Square waveform. The function of this waveform is y equals to when t between 0 to dt is a, when t between dt to t is 0. And we put this into our definition function. What we got is y RMS equals to 1 over t 0 to dt a square dt plus dt to t 0 dt, and it's 1 over t times a square dt plus 0. So for square wave, the RMS value is a times square root of d. The third waveform we're talking about is sawtooth, or we say triangle waveform. The function of this waveform is when t is between 0 to half of the period, it's 2a divided by t times t. When t is between half of the period, the function is 2a divided by t times t plus 2a. We also put this into our definition of RMS. We got y RMS equals to 0 to half of the period is 2a divided on t of dt plus half of t to t 2a times 1 minus t divided on t dt. And we all have our square root here. Long story short, we got the RMS value of triangle waveform is a divided on square root of 3. In this video, we first find out why we need to use RMS value, and then we talk about the definition of RMS value. Here we got our definition function here, and then we calculate 3 common waveforms of RMS value. For sinusoid waveform, the value is a divided on square root of 2. For square wave, the value is a times square root of d. And for triangle wave, we got the RMS value is a divided on square root of 3. That's all about today's video. Thank you for your watching. We will see you in next video.